Alright, I'm going to try to make this quick. We're going to skip section 1.4 just because it's kind of confusing at first, and I don't really remember it ever coming up during calculus a couple years ago the whole time. I think maybe we had one problem, and if that happens I can kind of just give you the basics enough to do one or two problems, but we don't need to do the whole section. So we're skipping it, going to 1.5, which I think is poorly titled. They say it's functions and logarithms. To me it looks more like inverses and logarithms, which is all about functions, but I don't know, whatever. So inverses, just a review of what they are real fast, and I am going to go fast, so you can watch this again if you need to. You can subscribe to my page. I've got like tens of subscribers now. I'm going to start getting paid soon. So inverses of functions, remember inverse means like opposite. So these are like opposite functions of each other. They undo each other. So if we have any function, I don't know, let's make one over 2x plus 1, just a basic line. We can look at it, the inverses of the equation itself. We can look at what an inverse looks like in the table, and we can look at what an inverse looks like in the graph, and they all kind of connect. So remember, if you've got a rule, an equation, and you're trying to find the inverse, just switch x and y, solve for y. Remember that? So x equals 2y plus 1 minus 1. X minus 1 equals 2y divided by 2. So your inverse, remember we write it as f, it's like to the power of negative 1. That's not really a power. That just means the inverse of f of x equals x minus 1 over 2, or if we want to write it in slope-intercept form, it could be like 1/2 x minus 1/2. So that would be the inverse of that. Graphically, remember inverses. If I've got 2x plus 1, see slope-intercept, y-intercept of 1, up 2 over 1, there's my slope, down 2. Okay, something like that. It's a line. Graphically, inverses, they're all just reflected over the line y equals x, which on this one is not going to, on my crappy paper graph here without graph paper, I can't really draw it. So remember, like if I had a crazy one like that, it always reflects over the line y equals x, so it'd be like, it should be a reflection. I'm not doing very good at drawing here today. So this one, if I ever graph it, let's see, shouldn't I don't know. See, that one should be steep. This one is not quite as steep. It should look like that, and they should be a reflection over that line. There's my crappy graph. You want more examples of that, just look in your book. Oh, hey, there's a good one. Oops. There's a square root graph and half a parabola. They're inverses of each other, and it's reflected over the line y equals x. Remember that? Alright. So then a table, remember, if I have my table for my original function and my table for my inverse, they should be flipped. So like this one, if I make a quick table here, let's just go 0, 1, 2, 3. Plug in those in, I'd get 1, and then I'd go up by 2s. So something like that. Well, my inverse, right, all the x's and y's just get switched. So you really don't even need to write this down if you just remember that stuff. So in a table, all the values just get switched. Graphically, it gets reflected over y equals x. And for a rule, switch x and y, solve for y. That's all inverse stuff. You can verify two things are inverses of each other without actually finding the inverse. And in your homework, you're going to be asked to do that. Like right here, it says in 13 through 24, find the inverse and verify a little composition of functions here. So f of negative 1 of x. So I'll do one of these examples. So I'll just do the easiest one, like 13. 13 says, I'll slow down a little bit here. I just had coffee, so I'm like going 100 miles an hour. So we got that. It says find and then verify that it is the inverse by doing a composition of functions. And if you, I think we talked about if you do this, if you compose the original function with the inverse, your final answer should just be x, if they're inverses of each other. So first let's find the inverse. So we'll switch x and y. So for y, so I get the inverse is, and I'm just going to leave it right now since I'm not graphing, x minus 3 over 2. Now to verify that I got the answer right, I do this. Remember this, you take the 1 closer to the x, so I'm going to take the inverse and I'm going to plug it in for x in the original. Remember that's what that means? So I'm going to take this x minus 3 over 2 and I'm going to plug it in for x right there. So I'm going to start over here, 2 times, now instead of x, I'm going to plug this in, x minus 3 over 2, and then plus 3. Alright, I think did we talk about this year or just last year? Sorry, I'm shaking the camera. So I got this, now you just simplify. Well, 2 times this, that's like 2 over 1, we're multiplying fractions, 2's are going to go away. That leaves you x minus 3 plus 3, well negative 3 plus 3 is just x. Boom. That tells me that those are indeed inverses of each other. If you plug one in, and you can do it the other way too, I can plug this in for x here, and if you simplify it, you'll just get x as your answer. So there's that. I think that's all I have to say about inverses. Except not all functions have inverses. For example, parabola technically does not have an inverse because it is not 1-to-1. 1-to-1 means, and you don't have to write this down, but the formal definition is f of a does not equal f of b if a does not equal b. So that's just saying if you have two different x values, the y values can't be the same. Or in a parabola, like say 3 or negative 3 and 3, two different x values, and if this is just y equals x squared, my y value for both of those is 9. Meaning it's not 1-to-1, therefore it has no inverse. Easy way to remember that? Don't remember that. Horizontal line test. We have the vertical line test to tell us if it's a function. This passes. Draw a vertical line anywhere. Yeah, it's a function. But it doesn't have an inverse. Because if I did the inverse, it would reflect over y equals x. It'd be like this. If your inverse is not a function, then it's not considered to have an inverse. Right? If I did the inverse, it'd be like that, and that's not a function. So you do the horizontal line test on the original, hits it twice, therefore no inverse. So anything, any kind of graph, absolute value is another one. Do the horizontal line test, if it hits it twice, doesn't have an inverse. Still a function, just doesn't have an inverse. And you'll see here, I'm going to assign 7 through 12, determine whether it has an inverse. Notice they don't have gray circles, so you can just graph them on your graphing calculator. Kind of do a little horizontal line test for yourself. It'll tell you whether it has an inverse or not. Okay, there's that, and I think that's pretty much it. Oh, last thing. Oh, you should know how to solve these exponentials. We were talking about it yesterday. You're going to have to log. The only one we haven't talked about is e. So if you have e to the x power equals whatever, I don't know, 5. To solve that, I'm going to need a calculator. Solve that, it's just an exponent. E is just a number. It's like 2.71 something. It's a regression. We'll talk about it more, where it comes from, what it actually means when we actually get into calculus. We'll just talk about it a little bit. I'm not going to go crazy about it. But it's just a number. So this is just a number to the x power equals 5. to solve that, as you know, you'd switch it to log form. So you would go log, and I always do it this way. I always go log this number to this power. I always draw a little circle in my mind. So it's this number to this power. Gives me that. Well, log base e is a special thing. It's got a special button on the calculator. It's called the natural log, or ln. If you look on your calculator, you got a button right there, ln. ln and e to the x are inverses. Oh yeah, I was going to tell you about that. So, just finishing this problem, I just had another thought. Just finishing this, I can just push ln of 5, boom, I got my answer, 1.609. That's it. I mean, that's just the same thing as if you had 2 to the x equals 100, you would log it, right? Because if you're trying to solve for x here, the inverse of an exponential is a log. They're opposites of each other. So that's why I have to switch it to log form. 2 to this power gives me 100. So same process. The only difference is on this one, when you have log base e, it's ln. That's what ln means. So when you see an ln, log base e. You know how to do this. I don't need to do it. I think that's it. You can handle this. Like I said, this one's going to be short. Tomorrow will be longer. We'll do properties of logs and graphing of logs. Be done with 1.5. Then get to the good stuff next week. Take a few quizzes, and then we'll actually be able to start calc. So here are some ones to try right now. Pause it if you need to. I'm signing off.